Okay. So Alfred Weber talks about three locational theories, which we discussed in the last class. One is the point of optimal transportation, which means the availability of your of raw materials and the distance that it is going to take, distance and cost that it is going to take to move your raw material to the factory. So that is one criteria you always have to keep in mind. Right now, what happens is sometimes raw material may be available at a cheaper price in a location that is far away from the factory, so it's available cheaply. So you go there and you buy it at a lesser price. But if your transportation, right, if the transportation cost is high because your factory is located far from where the raw material is available, right, so whatever you save in the cost of buying the raw material automatically will be spent in the transportation. You understand? Like, for example, a lot of people, I'll give you some practical examples. A lot of people go to Hosur. They may be living in Jalahalli and places like that, and they may decide to go to Hosur to buy crackers during Diwali. Now, why do they go to Hosur? Is because crackers are available at a lesser price. So what they do is they hire a cab or they take somebody's vehicle and then fill up fuel and then go all the way to Hosur because crackers are available at a lesser price. So they buy the crackers at a lesser price. So whatever they save is actually spent in that cost of petrol or in hiring that vehicle. So whatever they gain, they end up losing because they have to pay for the transportation to move all the way from Hosur to Jalahalli, right? So that is what you need to understand. So sometimes what happens, it becomes logical. You can go to Yashwantpur itself and then buy what you want, right? If you're living in Jalahalli, going to Yashwantpur and picking it up will automatically end up be the same price. So such kind of calculations also will have to be seen when we are making decisions. Secondly, right, labor distortion is very important. Now, if you want to go and set up your factory in a place where labor is abundantly available, right? If labor is available but they do not know how to do the job, then you'll have to end up spending money on training them. Or your factory is located in such a place where the real estate price is very low. You got land at a very cheap price, so you set up your factory. But around that factory, there is no labor. There are hardly any people living over there. Nobody is coming to work. So what happens is you have to pay them. You have to pay them to bring them from those distant places to come. So you need to transport them. You would have seen a lot of these construction workers traveling from their location in a tempo. This is what we call as labor distortion. Or like how IT companies or BPO companies, they are set up in some far locations. They're set up in Belandur, they're set up in Marathalli and places like that, right? But the labor that works, the people who come and work over there, those employees are all over Bangalore, right? So they pay on transportation. They provide cab facilities, they provide transportation. So it's a huge cost getting all of these people on time and trying to make sure that you start your shift, right? So you end up spending on transporting them. So that is another thing that we have to always look at. So you should always look at a trade-off. Excuse me, where you can create a balance. The location also should be ideal, and the availability of labor should also be ideal. The third thing that Weber talks about is a concept called agglomeration and agglomeration. Agglomeration is where a particular location or destination becomes uh, very attractive in the beginning. So a lot of demand is there. Everybody wants to go to that place. Factories are set up, businesses is set up, banking facility is set up. People travel to that particular place, right? So there is concentration of firms. This is what we call as agglomeration, right? Agglomeration is good until a certain point. We call this as until the saturation point, right? A city will continue to grow as long as it can contain. The moment it reaches a saturation point, the city becomes crowded, traffic becomes extremely high, right? And then there is a lot of stress and pressure, cost of living increases. So automatically it becomes a little difficult to live in that particular place because you don't get the quality of life reduces. So that is when a lot of companies, a lot of people in those cities will start moving out of that particular place because it's very crowded. They may start looking at tier 1 or tier 2 cities, right? This is a concept called agglomeration. So as a firm, you can go and set up in a city that is going through agglomeration because you get all the advantages that you want. You don't have to do anything. Like, for example, when you come and set up a business in a city like Bangalore or Hyderabad or Chennai, there is already an ecosystem. because these are cities that are agglomerating. They're continuing to grow and they continue to provide these facilities. So when you come and set up locations over here, you don't have to invest anything much, because everything is there in that particular place. You get labor, you get investment, you have banking facilities, you have good schools, you can live over there. Your employees are also very happy to come and set up in Bangalore, settle down in Bangalore. All of this is agglomeration. But once it reaches saturation point, then what happens is that location becomes unattractive. So companies will start pulling out. They may start going out of that place and start looking for newer places where they can go. So they will look for other places that are going through the agglomeration process, and that is what we call as degglomeration. Because of over concentration and saturation, factories will start moving out and start looking for newer locations where the cost of land, the cost of labor, all of that, it becomes a little more affordable. So Alfred Weber says, keep these three factors into consideration. Right? Good. On the same lines, keeping those three factors, right? We're going to look at location models, right? There are 5 location models that we are trying to understand to see which particular method can be taken. Like for example, when a factory decides they are looking for a new location, they may not always straight away identify one location and say that this is the best location. Like for example, when you go and buy clothes, you don't just go to a store and just pick up what you see first and then say this is the best, right? You make choices. You have 4 or 5 different shirts that you take, or 4 or 5 different tops that you take, and then you compare and then you pick it up. Very similarly, if you want to identify the best location, you should have alternatives. But what is the criteria that is going to help you to decide which particular alternative is the best? You have to evaluate them. You have to have a criteria. You should have certain variables. There should be some certain sense. If you say Bangalore is better than Hyderabad, Chennai, and Kochi, then there has to be some sense. There has to be some rationality. There has to be some justification. Right? So all of these are 5 different models that look at different dimensions of trying to see how factory owners can make a decision on identifying which is the best location. Okay, so let us look at each one of it. I'm going to give you a lot of practical examples for you to understand. First is identify the important location factors. Okay, so if you say Bangalore, Hyderabad, Kochi and Chennai, okay, let's take 4 locations. Your factory has 4 options, whether to set up in Bangalore, right? You want to set up this new plant in Bangalore, or you want to set it up in Hyderabad, you want to set it up in Kochi, or you want to set it up in Chennai. So 4 locations, right? And you also list down criteria. What is the criteria for any factory? Availability of land, cost of land, governmental support, state government support, or incentives, tax exemption, availability of labor, or growth of the city, cost of living, right? Nearness to the source of raw material, nearness to a port, or nearness to a buying center. So you can list down 12 criteria. Got it? You list down 12 criteria. So these are important. But once you list down 12 criteria, depending on the product you are manufacturing, depending on the type of industry that you are in, not all the criteria is equally important. When you write down 12 criteria, all the 12 criteria is not equally important. So what you need to do, you need to rank them. So if you have 12 criteria, right? So you need to rank them on the basis of which one is most important, which one is least important. So if you have 12 criteria, the criteria that you think is very important for your factory, if raw material, nearness to the source of raw material is a very important criteria because it has a strong influence over your cost of production, then you give it a 1 ranking. If availability of quality labor is a very important criteria after cost of raw material, availability and cost of raw material, if you think availability and cost of labor is very important, no, that is the second important, you give it a rank 2. Right? Like that, you continue to rank all the 12. The most important will be from 1, 2, 3, 4, 5, and the least important will be 10, 11, 12. Got it? So you do this for each of the location. So the 12 criteria, you see that for Bangalore. right? In terms of Bangalore, is Bangalore good when it comes to availability and cost of raw material, availability and cost of labor, quality of life, governmental support, availability of land, tax exemption, like that you listed down criteria. So you will see whether Bangalore has any of those criteria. So Bangalore, so you rank Bangalore also on those criteria. Then you go to Chennai. You see availability of source of raw material. Does Chennai give you that availability? So for each of the 4 locations, you are going to see whether those locations are able to fulfill your criteria. Right? So you do that for 4 locations. So you have a certain matrix that you create. You will create a certain table with all the 4 locations with all the ranking on the basis of which particular location gives you what advantage. Like for example, availability of land in Bangalore, maybe you would have given the first rank because availability of land is there. Availability of land in Kochi, you may not have given because compared to Bangalore, availability of land could be rated 5 in Kochi. In Bangalore, it is rated 1. It is rated 5 in Kochi. It is rated 4 in Hyderabad. It may be rated 6 in Chennai. So like that, each of the 12 criteria will be given different ranking according to whether those locations are able to fulfill. Based on that, you multiply your factors based on the various criteria that you have. You multiply those factors, and you are going to identify which particular location gives you the highest total. When you multiply those factors, the sum of those products, so whichever location is able to give you the highest location, highest value will be the location that you consider, because that is the location that fulfills all the 12 criteria that you are going to have. Right? So out of the 12 locations, you will identify whichever location has the maximum total, the highest total score. Now that location is what you will choose for deciding as to this is the location or the city where I will have to set up. Right? So here is an example for you. Right? So this is for a hospital. Right? So we've used this example for a hospital. Right? So what is the criteria, location criteria? We have facility location, facility utilization, then we have total patient per month, average time per emergency trip, land and cost, construction cost, and employee preference. Where do they want to go? So we have given them ratings. So the rating is given. This is location 1. So whether you want to set this factory, whether you want to set this hospital in Hennur, location 1 is Hennur. Okay. So whether all of these 5 criteria, what is the ranking that you will give, or how important in terms of that scale of 1 to 5, how important is this in this particular location? So in location 1, if it is location 1 Hennur, on a scale of 1 to 5, what is the value that you are able to get? What is the value that Hennur is able to fulfill for any of those 5 criteria? Then you may take location 2, maybe in KR-Puram. So you may take KR-Puram as your second location. And then you find out, if I set up a hospital in KR-Puram, on a scale of 1 to 5, which particular location gives me the value? Right? So what happens is you have your rating over here, and then you have your location. Location 1 is here, then you have location 2. You need to multiply your rating with each of the location values that you have. So 8 into 3 will be 24. 8 into 5 will be 40. So you create that value table. So next to location 1, you can create one more column, and then you multiply the sum of these squares. So you can write this as total value for location 1, total value for location 2, and then you multiply the criteria, and then you add that sum up for location 1 and location 2, and then you tell me which particular location has the highest score, so that you can decide that that is the particular location that we would want to go. Okay. All right, do that, and give me the answer in the location. Give me the total for location 1 and total for location 2, and tell me which one has got the highest value. You got my point, right? You're working on it?
Yes, sir.
Yeah, do that. So each of this rating is multiplied with the location. So you create another column after location 1. That will be the sum total, and then you are going to multiply the rating into location 1, and then you put that sum. And once you finish that, you see the total that location 1 is getting, and then you create another column after location 2, and then you multiply rating into location 2, and then you see what is the total, and then you multiply that, and then you see what is the total sum, and put your answer in the chat. Location 1 is 96, 96,106. Okay, 96,106. So between location 1 and location 2, whichever location has got the highest score, so that will be your most preferred location. So I have Jivita and Harshita both giving me the answer. So when you multiply the rating with the location 1, and then you add up the score, so location 1 is giving you a total value of 96, and location 2 is giving you a value of 106. Good. So whichever location is able to give you the highest value, right? So in that previous example, if location 1 is Bangalore, if location 2 is Chennai, location 3 is Kochi, location 4 is Hyderabad, and we want to open a plant. So if you have 12 criteria, you are rating each one of the criteria on the basis of their importance, and then you have each, right? Which particular location gives you that advantage? If you set it up in Bangalore, what is the criteria? Set it up in Chennai, what is the criteria? So each of these locations will have different value. Once you multiply those factors, automatically you will be able to get that. So that is a very simple, simple and a very rational kind of way of doing it. Like what you see here. So the answers are right. Almost everybody has got it right. So location 1 is giving you a total score of 96. Location 2 is giving you a total score of 106. So the location in factor loading method, whichever location is able to give you the highest score, now that is the location that we will choose. Rather than simply saying location 1 is good or location 2 is good, we are taking very important factors, and then we are assigning ranks, right? And then we are multiplying based on the preference that each one of this location is able to give on the basis of the ranking, and whichever location is able to give us the highest score, we do that. Okay, so that's the first very simple method that we can use. You can use this for almost any practical example. Any simple example also, you want to make a decision, you can do that. Right? Very simple tool that can be used for almost anything. You want to buy clothes, you can do that. You want to take up a house for rent, you can do that. You want to take up a PG, you can do that. Or you want to decide which mess is better in Narayanpura. You have 3 messes. So which mess is better? Right? You can logically do this. You just have to put the criteria. What is that you're looking for in a mess? Put 5 criteria. Then you see, make that comparison. Right? How does each mess or each PG evaluate on each of the 5 criteria, and then you logically conclude and say, yeah, this is the way, this is the particular PG or mess that is considered best because it helps me to fulfill whatever is my criteria. Okay, this is a very simple method to follow. The second method is the weighted average method. right? What is the idea in finance? You do weighted averages, right? What is the idea behind the weighted average method? What is the logic behind the weighted average? Anybody? Where do we assign weights? The weighted factor. When do we assign weights? Anybody? When do we assign weights? Anybody has an answer?
When there are different measurements, sir.
Okay, when there are different, see, sometimes what happens is factor loading method becomes a little complex. It may not be very easy for you to say whether this is the rank that you want to give to Bangalore, Kochi, or Chennai. Sometimes it's very complicated, very difficult, because all of them may almost be equally good. They may not be exclusive. If they are 4 different locations giving you 4 different location factors, then it's easy for you to assign. But sometimes what happens is it may be a little complex for you to make this decision. You may not have all the data. You may not have all the data with you to make that decision. So in that particular case, what you do is we assign weights, which means what happens is you have a total of 100 points. You, for each of the 5 criteria, you are going to assign points. So out of 100, how much would you want to distribute, right? So out of 100, how many points would you want to distribute is what we do. So what we do is we assign weights. We assign weights for each of the criteria. So let us look at another example. This is slightly different from the same example that we look at. So the same example is what we are taking. But there, instead of the factor, instead of ranking the factors on the basis of their preference, we are assigning weights. So out of 100 points, I'm telling facility utilization is important for a factory. How important is this criteria? Right? So facility utilization is very important. So I'm giving 25 points for it. The total number of, total patient per kilometer per month, right? So that I'm giving, that's also equally important. How many patients drop in per month is also very important. So I'm giving 25 points for that. Then average time per emergency trip. How quickly can a patient reach the hospital? Within a radius of about 10 kilometers. How many patients are we able to cover in that population? So that's also very important, because when people are in an emergency, they have to look for the nearest hospital, right? If the nearest hospital is within a radius of 10 kilometers, people will say, okay, why don't we go to this hospital, because this is very close. 25 points. Land and construction, it is going to cost almost the same. Wherever you construct the land or wherever you construct, it is going to be, the cost will be remaining the same. So compared to the first 3, you are saying 15, the land and construction cost is 15. So it is not so important. And then employee preference is also not so important. So this adds up to, right, 95. So this adds up to a total weight. So like that, another 5 you can assign for any other criteria. So we have the same thing over here. So location 1 is here, location 2, the same criteria that we have given, for 2 particular places where we want to take it up. So on the weighted average, right? So what we do is we calculate these distances. We calculate the distances on the basis of the weights. So 25 into 3, and whatever is the value, 25 into 5, whatever is the value, that's how we are able to do it. So the only difference in the factor loading method and in the weighted average method, in the factor loading method, you are assigning criteria on the basis of ranks as to which particular criteria is important. Here in the weighted average method, instead of assigning ranks, you are assigning weights out of 100 points. Whether you have 5 criteria or whether you have 10 criteria or 20 criteria, you still have 100 points only. With 100 points only, you have to decide which one I should give more. This is called like a forced method, where you have just 100 points. You have to equally distribute it among 5 criteria or 10 criteria. So, but depends on which criteria that you consider is the best. And those weights are going to be multiplied with each of the locations, like how you did it in factor, and then you will be able to get that score. Okay, can you all do this? $315. So location 1 is 315, location 2 is 335. 315, 360. 315, 360. Any other answer there? Okay, Vatsala, 315, 335. 315, 335. 315. Just give me 315. What is the second location value? 335. Okay. 315, 335. All right. So 315. So location 1 gives you a value of 315. Location 2 gives you a value of 335. So whichever location is able to give you the highest value, or the total score is greater than any other location, then that is the location that we prefer to choose. Okay. Two simple calculations, right? One is based on the ranking, the other is based on assigning of weights. Simple. Right. Third decision that we are taking is on the basis of load distance. Load distance. Here we take two factors into consideration, right? Distance. So when you set up a factory, like what Alfred Weber spoke, the first two criteria, he says the raw material distance, the cost of the raw material and the distance that the raw material has to travel to the factory, or the cost of labor and the distance that the labor has to travel to the factory, right? So when we set up, when we decide two or more locations, we are trying to see this, right? So that's what I told you. Sometimes what happens is the cost of labor may be cheap, but the factory may be very far away. Cost of labor may be cheap, but the factory may be very far away. So commuting to and fro can be very expensive. So some of these labor workers may not be willing to come. So if the factory wants these workers to come, then they have to provide a transportation. Got it? So when you locate it in 2 or 3 different places, what is the load distance for material to travel to the factory or labor to travel to the factory, or in the case of the hospital, for patients to travel to the hospital, right? Now that is where we try to see the load distance, because unless and until you have raw materials coming at a cost effective rate, or labor coming to that particular location in a cost effective manner, or more number of patients coming to that particular hospital, right? Everything will make sense, right? Only when it is being consumed, only when the facility is being completely utilized. So that depends on load. So you have to make a trade-off. It has to be a win-win situation. Win-win situation is you should be able to locate your factory in a location where land is available at a cheaper price for you to start a factory. Correct? Then if the particular location is also close to the source of material, then it's a raw material, it's a win-win situation. But if you end up going to a location where land is available cheap, but the raw material is at a distant place, then transporting raw material can be very costly. Right? Now, what if it is very inevitable? Right? Whatever location you see, you are only getting this criteria that all the locations are far away from the raw materials. Right? All the locations that you have chosen are far from the source of raw material. There is nothing that is close to the source of raw material. In that case, you can take the load distance. So what you're trying to find out is which particular location is minimal, has the minimal distance. Between all the 3 locations or 4 locations that are far away from the source of raw material, which particular location is closest to the factory is what we will consider as the best location. So that is where we use the load distance method, right? So this is the formula that we use, right? So if you have 2 areas that you're looking at, 2 locations, right? So you're going to look at DAB is equal to XA minus XB plus YA minus YB. So those are 2 coordinates. We're trying to find out which particular coordinate is better for us to make a decision. So if you have two locations, between location 1 and location 2, there is going to be a criteria that is going to be decided, and then you're going to find out the value. What is the value that you will have to find out between each of these coordinates? What is the which is the location that is going to give you the highest value, right? So we're going to look at that. This is an example that we are giving. We're taking a health center. Can any one of you read this loudly? Alexander, can you read this?
Yes, sir. The new healthcare facility is targeted to serve 7 census tracts in Delhi. The table given below shows the coordinates for the center of each census tract, along with the projected populations measured in thousand.
Okay,
Customers
let me
will
explain this. Yeah.
Okay.
So there is this particular hospital that wants to locate it in a place. You know, this is in northern, we're looking at Delhi. Wants to set up in a location where they are targeting 7 segments, 7 census areas, which means 7 localities. They're looking at 7 localities to whom this hospital is going to cater to, right? So they're looking at that. So right now we have the population of the 7 areas, 7 districts. So we may have the population of the 7 districts, and we also have the projected population in the next 5 years. How many more additional people are going to be added? Okay, so that data is available. So look at this logically. When we set up a location, you know, we are looking at how we can cater to maximum number of customers. So here is this hospital that is looking at in which particular place, if I set up, I will be able to cater to maximum number of patients. So they have taken 7 different areas, 7 areas. The population of the 7 areas is given, and the projected population in the coming years also is given. Okay, next. Continue, Alexander.
Customers will travel from 7 census tract centers to the new facility when they need healthcare. 2 locations being considered for the new facility are at 5.5 and 4.5 and 7.2, which are the centers of census tract C and F. Details of 7 census tract centers, coordinate distance along with the population for each centers are given below. If we use the population as the loads and use rectilinear distance, which location is better in terms of its total load distance score?
Okay, so what has happened is those 7 areas. So what this hospital has done is it has tried to identify the load distance from each of the 7 areas. So A, B, C, D, E, and F, right? They have taken all of these areas, right? And they've identified C and F, A, B, C, D, E, F, and G. So 7 areas are A to G. So each of these areas are identified with the alphabet. So A to G are the 7 areas. Of the 7 areas, this hospital has found out if we are going to locate it in area C and then area F, those two will be equidistant. So people from any of the 7 neighborhoods or areas can travel to that particular place. So this is the coordinate. The coordinate value is 5.5 and 4.5 for C. And then it is 7.7 and 2 for F. So these are the coordinates. So between C and F, we need to find out what is the distance, the load distance for each of the patients if they have to travel. So this is the data that is given to us. Okay, so you have A, B, C, D, E, F, G. Those are the 7 areas. And 2.5 and 4.5 is the criteria that is given. This is the coordinate for A. Coordinate for A is 2.5 and 4.5. The X value for area A is 2.5. The Y value for area A is 4.5. Similarly, the X value for B is 2.5 and Y value is 2.5. For C, it is 5.5 and 4.5. For D, it is 5, 2, 8, 5, 7, 2, 9 and 2.5 respectively. So this value is given. The population for each of these 7 locations is also given in thousands, in lakhs. Okay, so in area A, it is 2 lakh population, area B is 5 lakh population, C is 10, 7, 10, and 20. So here what we have found out is this particular location, 5.5, right? Area C and area D, this is where the population is very high, C and F. So the factory has come to this conclusion that if we are going to set up this factory, set up this particular hospital in area C or in area F, right? So because this will give us equidistant, that will be equidistant where people from any of these 7 locations can travel, right? So how we do this is we take this formula, DAB is equal to XA minus XB plus YA minus YB. So what you do here is you have your X and Y value that is given to you, right? So this is where you have the 2.5 and the 4.5. So you put this particular value. Population is also given to you. So what is the criteria that is given here? 5.5 and 4.5, right? This is for location X. Location C is 5.5 and 4.5 coordinate. So that is the central value. And 7.0 and 2.0 is the value that is given for F. So you need to be able to calculate this. So how do you find out the distance, right? So how you find out the distance is 2.5 x minus XA minus XB. So 2.5 minus 2.5, 5.5, XA minus XB. So 2.5 minus 5.5 will give you 3, correct? 4.5 minus 4.5 will give you 0. Right? So like that, you need to calculate for each of this value here. So 2.5 minus 5.5, 4.5 minus 4.5, that is the X value. So you put that value over there. 2.5 minus 5.5 and 2.5 minus 4.5. So what is the value? Like that, you need to do that for X and you create another table like how we have done here. Are you able to see this? So this is the formula that we are using, XA minus XB. So 2.5, this is XA, right? XB will be 5.5. So we are taking 2.5. So 5.5 minus 2.5 is 3. 4.5 minus 4.5 is 0. So 3 plus 0 is 3. Like that, you do that distance. You're identifying the distance value for each of the coordinates, each of the 7 areas, right? So when you are using the central value 5.5 and 4.5 and then you minus the X and Y values, you automatically will get these figures. This has to be multiplied with the population. When you multiply with the population, you get the load distance and then you have the total load distance of 239. Similarly, the central load distance is 7.2, right? For location we are giving here. So 2.5 minus 7, 4.5. 4.5 minus 2 is 2.5. So we're not taking the plus or the minus value. Whichever value is what we are getting. Whatever is the score we are getting is what we are taking. The plus or minus does not make a difference. So 4.5 minus 2, 2.5. 2.5 minus 7, 4.5. 2.5 minus 2 is 0.5. So like that, you calculate the load and then you multiply the load, the distance with the population. When you multiply the distance with the population, you get these scores and then you are able to arrive at the score. So 239 and 168 is what you're getting. 239 is for census tract C and 168 is for census tract F. So summing the total of all the tracts given, a load distance score of 239 when the facility is located at C versus a load distance of score of 168. So what we do is between 238 and 168. In this between C and F, so C has got a score of 239, F has got a score of 168, whichever is the lowest value. Please remember, when we calculate load distance, we are taking the total that is the lowest to be the best. So between 239 and 168, 168 is the lowest score. So we decide and say that between C and F, F is a better location. Please remember this. When we do factor method, we take the highest value. When we take weighted method, we take the highest value. Whichever location has the highest value, we decide and say that is the best. But when we are calculating load distance, we're trying to find out the value that gives us the lowest distance. So that is a distance that is comfortable. Whether location C is accessible to all the people from the 7 areas, or location B is accessible, because based on this particular value, we say, location F is more accessible. So the value that you get as the lowest will be the best in terms of location. Okay, another very simple problem that you can take. That is the third method that we have. So you are going to use, see these values will be given to you. If you have a problem, these central locations will be given to you. 2 locations, and those location there, quadrants will be given to you. So all that you have to do is and the data about X and Y and the population will also be given to you on the problem. You just have to identify the load for each of the areas. Find out the load for each of the value, multiply that with the population, and then sum it up, and then you will get a total value. When you total the load distances, you will get a total. Whichever total is the lowest is the best in terms of identifying a location. Very similar to that, we are using another model called the center of gravity. Right? The center of gravity also is trying to create a balance. Between, so that wherever we set up our factory, we should have a win-win situation. We should be able to match well on all the 3 criteria. So that is where we use the center of gravity. The load distance was talking in terms of how the central criteria is going to be fulfilled, whether it is raw material or whether it is labor or whether it is the patients coming in. Like in the previous example, the hospital wanted to make sure that they get maximum patients from one particular location. Here in center of gravity, we are trying to see how 2 or more criteria that we have can be fulfilled. Right? This is basically to ensure that the total cost is low. And then we are able to balance the cost of production and profit maximization, so that we are able to set our factory up in the best location, ensure that we are able to buy land at a lesser price. Construction cost is also a lesser price. The setup cost also is low. Availability of raw material, cost of transportation of raw material is low. Availability of labor is low. All of that is low. And then we should be able to produce high volume goods and then be able to sell to maximum number of customers. So basically the cost benefit analysis is what we're looking at. How can we ensure a maximum cost benefit, right? Where the location of plant and market also is convenient. The volume of goods that we are manufacturing and selling also is optimal. And then the transportation from the raw material source, from the warehouse to the factory, and from the factory to the market is also the lowest. Right? How 3 or more criteria can be fulfilled? How do we identify that? That is where we use the center of gravity. Right? The center of gravity minimizes the weighted distance between the warehouse and its supply point, like how I told you, from the raw material source to the factory or from the factory to the market. Right? So we're trying to find out which location gives us the best advantage. Right? The first step is to place the locations on a coordinate. We try to put that on a quadrant, each of the locations. Like for example, if you have 4 locations, you try to plot them. The origin of the coordinate system and the scale used are arbitrary, which means where it is starting and where it is ending is arbitrary. It does not have a fixed starting point. So on that particular coordinate or on that particular graph, you can always plot it. Then you use a grid, right? Grid over an ordinary map, which is nothing but a graph. You can take a graph sheet, divide that into 4 quadrants, and then you can decide based on the location where exactly you would want to fix it up. So 7 locations can be plotted on a graph, and then you try to calculate the weighted loads. So we're using the same method, right? So you have A to G, and then we have the same population index is given, as well as the distance between X and Y is also given. Okay. So what you're doing here is, right? So you are calculating the center of gravity distance. Now, how do you do that? Is, right, X into L, right? So you multiply to find out your population for center of gravity. Earlier in that previous exercise, in the load distance, you were given coordinates for C and coordinate for F. So you had to minus that and then you had to do that. Here you are going to be multiplying the X coordinate with the population. So 2.5 is going to be multiplied with 2. 4.5 is multiplied with 5. Right? So when you 2.5 into 2 will give you 5. 4.5 into 5 will give you, into 2 will give you 9. So like that you calculate, so you get these values. Right? So this population total is 68 lakhs. You can total that. And then once you are able to get the L into X, right? 2.5 into 2, 2.5 into 5 will be 12.5. 5.5 into 10 is 55. 5 into 7 is 35. 8 into 10 is 80. 7 into 20 is 140. 9 into 14 is 126. Similarly, 4.5 into 5 is 9. 2.5 into 5 is 12.5. 4.5 into 10 is 45. 2 into 7 is 14. 5 into 10 is 80. Like that, you get these values. Then you add this up, 253.50. So now you need to find out which particular location is where the center of gravity is the lowest. Right? So 453.50 divided by 68 will give you 6.67, and 205.50 divided by 68 will give you 3.02. So those are the two locations where those are the new coordinates. The new coordinates where you can plot them, and that is where you are going to say that this particular coordinate will be the best. So 3.20. Using that particular method, 3.2, that particular location will be the best. So that is where you are considering in terms of the center of gravity, right? To say between location C or location F, 3.2 will be the coordinate. So you can plot that on that particular map where you have all the different locations are plotted. So wherever in that coordinate you are able to get the location 3.2, now that is where you will plot or locate it and say this is where if we set up a factory, which will be equidistant to all the 7 locations. So that is where you are identifying this new coordinate, and then you are able to say that yes, this is the location that will be the ideal. So that is where we can use this particular method to decide. But this can be used provided you have data. The load method as well as the gravity method can be used provided you have accurate data. Accurate data should be available for each of the areas. Population also has to be accurate. Projected population in the coming years also has to be accurate. Then your cost also must also be available. You know how much, what cost you are spending. What is the cost of raw material, cost of land for each of the locations should be available. So you can do this for as many number of areas as possible, right? So the difference here in the load distance, we had already identified C and F. Between C and between F, we were trying to decide which location is the best, right? So we found out that location F was the lowest, at the lowest score. So we decided that to be the best location in load distance. Here what happens is, now we are not deciding as to whether it is C or F. We are trying to find out a new coordinate where if we locate on the map between wherever 6.7 is joining on the x-axis, 6.7 is the new plot on the x-axis, 3.2 is the new plot on the y-axis. So when you draw that graph x and y, right, and when you put 1 to 10 and 1 to 10, right, on the x-axis, wherever 6.60, so you make a plot over there, and then on the y-axis, right, from 3.2 where it is. So wherever 6.7 and 3.2 is going to intersect, that is going to be the location where you have to start the factory, because according to the center of gravity, now that is the location which is closest or equidistant to all the 7 areas, right? So you are identifying a new coordinate, you're identifying a new location which is closely equidistant to all the 7 localities where patients from all these areas can come to that particular place. So this is how this particular method is followed. Please remember that. In load distance, two areas and their coordinates will be given. You have to find out which particular location is the best. But in center of gravity, you have to identify the new coordinate. So the new coordinate will be identified by adding up the total population and then finding out the load, the gravity distance by multiplying x into the population, right? And the y into the population. So both of that will give you that, and you need to divide that by the total population. So you'll get 6.67 as one value for x, cx value is 6.67, cy value is 3.2, and then you have to plot that on the graph and say this is exactly where the new factory can be started. So it makes a very sensible thing, provided you have the data to validate all of this. Right. So another very popular method that we use, right now, though break-even analysis is very often used to identify whether the business is making profits or whether it is making losses, and also to identify the time duration. Right now, this can also be identified. Right now, how do we use this in making a location distance? Right, in which particular location, if you start your factory, will you be able to reach that optimum output? Which location will help you to manufacture the optimum output? Like if you have location 1, 2, 3, 4, 5. So when I said Bangalore, Kochi, Hyderabad, Chennai. So let us say you're manufacturing, you're setting up plant. You're logically thinking you're going to set up a plant in all the 4 locations, right? In which particular location will you be able to break even quicker? How sooner will you be able to break even? Right? And what is going to be the break even value? Right? What is the output that you're going to reach? How quickly are you going to reach that output? That is the first criteria. Second is, in what time duration will you be able to reach that output in each of the locations? So based on whichever location is going to help you to break even quicker or sooner. Now that is the location that you will identify and say that this is the location where we will break even soon. And why you break even so early in one particular location? Maybe because of the favorability of several factors that are there in that location. Availability of land, cost, everything will multiply, right? And then you will be able to achieve that. So break even point, as all of you know, you've already done this in finance and other classes. So the break-even point is calculated dividing the fixed cost divided by the selling price minus the variable cost or cost per unit, right? And then break-even point in terms of units, that is a formula that we use. So fixed cost divided by contribution margin. And then we have break-even point in terms of rupees. Break-even point in dollars is equal to selling price, sales price per unit into the break-even point in units. So you multiply that, you will get your break-even point in rupees. And then break-even analysis is based on the desired profit. Now, what is the projected profit you're looking at? Desired profit in rupees divided by the contribution margin per unit. The formula is the same, so it does not change. Whatever is the break-even formula that you all have been using, that is the same formula that we will be using for this as well. So here is this location. So we want to find out whether location A you will break even quicker, or in location B you will break even quicker, or in location C that you will break even quicker. So potential locations are A, B, and C. They have the cost structure shown for producing a product expected to sell at rupees 100 per unit. The selling price was also given 100 per unit. Find the most economical location for an expected volume. So expected volume is 2000 units per year. The selling price of the unit is 100 rupees, right? And also determine the range of annual production for which A, B, and C locations would be most economical. So if you are setting up in location A, fixed cost is 25,000, variable cost is 50. If you are setting it up in location B, fixed cost is 50,000, variable cost is 25. In location C, it is 80,000, variable cost is 15. So apply the formula and then you tell me which particular location is ideal, or which particular location, if you locate, you will break even sooner. So all the information that you want is there in the problem. It's a very simple exercise. Anybody getting the answer? Selling price is there, 100 per unit. Expected volume is 2000 units per year. Fixed cost is for each of the location is given.
Sir, after finding BEP,
Yeah. Have you found
how
out the
to-
BEP for each of the locations?
yes, sir, 500, 666 and 941.
Put it in the chat. Let us see whether others also have got it. So location A is, what is the answer, Bipin?
500.
500. 500, 666 is it? Jivita has put it 500 for location A. Break even volume is 500, 666. Yeah, very good. 640, 941. Good, you'll have got the answer there. Right, so we understand this is just a diagram for you to do that. Okay, now what are we expected? Also determine the range of production for which A and B and C would be economical. So we have 500, we have 666, and we have, so which particular location is ideal? Between A, B, C? Which location would you say, according to the break-even point logic? In which particular location will you be able to break even soon? So the break-even volume is, in location A is 500, in location B is 666, in location C is 941.
Sir, location C, sir.
Yeah, location C. Good. All right, so that is how these problems will be. So it will be the break-even, problem itself. Like how what you've been doing in finance is what you will also be getting it. Only thing we are applying it logically in terms of identifying which particular location where we can economically manufacture. Right, so that is where these figures, projected figures will be there. What is the expected price at which we want to sell? What is the volume we want to, because volume also will help us to decide which particular location will help us to reach that volume. Okay, right. So those are the different models that we have. So these are 5 different models, very simple examples, very simple problems to help you to identify. So there may be 2 or 3 different problems. I'll give that as an exercise so you can work it out at home. Some of these problems will be very useful for you to understand. All right, so with that, we come to the end of module 1. This was the last topic that was stuck. So from the next class onwards, module 2, we have material requirement planning, MRP, vendor analysis, and so on. So that's module 2. So from the next class onwards, we will have the classes going combined.